Fantastic. Well, we're 2 minutes in. Let's get started. Thanks everyone so much for joining. My name's Toby. I'm part of the team at Factor House. But you're here today to hear from a star of the show, which is Karel. Karel, I'll let you introduce yourself and get started with the presentation.
Thank you, Toby. Hi, everyone. I'm Karel Alfonso Sague. I have two surnames. I'm a staff engineer at Factor House, and I previously used to work for Block and a consultancy called ThoughtWorks. Today, I'm going to be talking to you about a real-world experience in a journey to migrate some data assets and workloads over to an open lakehouse. This is going to be related specifically to Apache Iceberg, but I intend to cover some of the topics around this side of the lakehouse technology. My goal today, so I'm going to structure the webinar by going through a bit of a history, how we got into the lakehouse. Then we're going to look at the table formats that are the core of powering the data lakehouse as a technology. We're going to talk about Apache Iceberg as a leading format, the experience that I went through, not myself, but within the team, migrating to Apache Iceberg. We're going to look at some of the strategies and then wrap up with a look towards the future, what's happening there. And so we get started. So as a bit of context, I guess most people not so sure in terms of familiarity with data architectures, but throughout the last decades, we've been moving through different styles of data architectures. From the late 1980s, we have data warehouses, which were a solution to get operational data sources and external sources into a highly curated form of data with a well-defined structure. You get the different approaches in terms of modeling, and the use cases that the data warehouse powered were usually around business intelligence and reporting. Later on in the 2010s, with the raise, the MapReduce from Google, there was this drive and push to get all different sorts of sources, not only from operational data stores, your traditional databases. In this case, you can have images or videos, click streams, log files, etc., uploaded into what they call a data lake. This is a concept that was introduced around 2010 by James Dixon from Pentaho, and it caught on quickly. And with the rise of Hadoop platforms, this was another data architecture that became mainstream, and there was a huge effort to build these data lakes. I myself worked across at least two of these efforts in past organizations. And one of the things with data lakes, and you keep hearing about this, is how many of these efforts failed in practice. And doing some research for this webinar, I managed to, I found this interesting, this an article, a paper. It was from, I think, published a couple of months ago. What went wrong with data lakes? And in this paper, the researchers, they captured 7 deadly sins of data lakes. I captured here 3 of the main ones that I think are quite relevant for the topic that I'm going to present. One is that in the data lake, there was one of the main problems was the ingestion without purpose. And this was the drive to ingest anything. I don't know how many of you here lived as practitioners through this decade, but it was like upload all your data to data lake, and from then on, you work out the schema and produce the applications of the reporting. The second problem was the schema avoidance. So instead of having highly curated structured data coming from the operational data sources and building this data mass from the data warehouse, the approach was upload your sources as is and then work out the schema on read, which that created lots of issues. And then there was a governance as an afterthought, because once you have a bunch of data in your data lake, this could be in object storage, could be AWS S3, could be Hadoop file system. You have a bunch of data, then you need governance. Is this data available for consumption? Who owns that data? What is the schema of that data? So this All these were major issues with the data lake architecture. So it's not surprising that a few practitioners and companies in this space wanted to come up with a solution. And the main driver, the main company that drove the new wave of solutions was Databricks, with the concept of a data lakehouse architecture. And what they aimed to do was get the benefits that you have from data warehouse and the benefits that you have from data lake, and put them into a new data architecture, what they ended up calling the data warehouse. So there were some other features here that I haven't mentioned in data warehouses and data lakes, which is around the consistency of the data, having acid properties from databases, where you have the tables when you're running to them being consistent, atomic changes, all that were issues as well. And that was the next data architecture that to this day is what is powering some of the new solutions at organizations. So a lakehouse has the common features that you find in data warehouses, where you have well-defined schemas. Ideally, depending on the table format that you use, you will have atomic acid transactions, and you can also have all the other data sources like you used to have in data lake. It could be JSON files, click streams, and logs. And this is now gives you a level of governance where you can, across the board, potentially power multiple use cases, not only business intelligence and reporting, but also machine learning and streaming analytics, data science. We're going to look into some of them here. But let's go back to the experience that I'm going to talk about here, this particular migration to an open data lakehouse. So in some organizations, I'm pretty sure this will be quite common, you will have not only a data warehouse, but also some data lakehouse or data platform like Databricks, or some of the data platforms from your cloud providers. The problem that I found myself or my team was being part of the data platform, that there was lots of data duplication. So you have your applications, each of them with their own operational data stores, and you want to build different use cases, either reporting, analytics, business intelligence, but you want to use different data platforms. So we found that as data platform team, some of the product teams were duplicating the data across Snowflake and Databricks and building different replicas. So it was very hard to know exactly what was the right data source, what was the one that you should use for different use cases. So duplication of data increased cost because of the different storage. The vendor lock-in is that some teams wanted to use Databricks for at the time for specific use cases. In some instances, they had to go via Snowflake. While they are connectors, they preferred an approach where they could access data from Databricks. And there was complex governance as well. So as a data owner, if you have some highly regulated data sources and you have that data in Snowflake and Databricks, now you have to duplicate the governance and the role-based access control, etc. So with the data lakehouse, we're thinking about what would be a good approach here. We wanted to have a single source or a place where we could have a single source of definition to govern the data, the quality, the ownership, the permissions. We want to have one single storage and allow multiple compute engines to access the data. So in that case, in this particular case experience that I'm referring to, we had Snowflake and Databricks, but some other workloads were using Apache Spark in AWS, and we want them to query the data as well. And we wanted to base it on open standards. So even when we're using our own vendors for data platforms and cloud, we wanted to at least use and leverage open standards. So this when we started thinking, what do we do with our data sets? at the organization. While we had a data warehouse and we had some data assets replicated into Databricks, we started thinking about open table formats in the industry. This was around 2023 or 22. So at the time, Apache Hive, which was created around 2010, was the standard table format in your data lake. And there were some issues there, especially with asset transactions at the time, how to manage schemas, how to partition the data, look at the data across different moments in time, and their performance. So we did an analysis of, at the time, the table formats that were available. Apache Hudi, Apache Iceberg, and Delta Lake were the ones that, at least from maturity point of view, were showing up to be the next upcoming table formats. I'll explain quickly what they are. But we decided to take a look at both of them, especially Apache Iceberg and Delta Lake, and make a decision about which one in the future will be the one that we should be basing our data sets on. This was quite difficult moment at the time. Apache Iceberg, so there was it's framed sometimes as a war, but it was a lot of confusion as to which one of these table formats you use. And so if you're not familiar with table formats and Apache Hive, they give you a table-like view of your data files in the storage. So in the data lake, Apache Hive was traditionally the table format, but these new ones were trying to cover and improve on the issues with Apache Hive. All of them, at a minimum, will give you a table-like view of your data in the data lake. Otherwise, you'll be looking at a bunch of files. So there were lots of discussion at the time. Apache Iceberg was shaping up to be the table format that was going to succeed, especially from the openness of its specification. And we had lots of conversation at the time with some of the Databricks folks as well. At the time, it was quite troublesome, but solutions like Uniform and Apache Xtable were created, and they allow you to have a layer of interoperability between all these table formats, because all of them, what they give you is a bunch of metadata to describe the files that you have in the data lake, but they're different. So these technologies, Uniform and Apache Xtable, gave you that layer of interoperability where you can have a table in one, let's say in Delta Lake, and then it would generate the metadata for Iceberg. And that way you can create the table. But whether Iceberg won or not, I'm not so sure about that, but certainly from what you can see right now, and you can look at this in the Iceberg open source page, there's a wide support across all the cloud providers and data platform vendors for Apache Iceberg. We'll talk a bit more about the direction here towards the end, but we decided to settle on Apache Iceberg at the end. And essentially, from the problem that we were facing, duplicated data assets, the lack of governance, we thought if we move towards Apache Iceberg as a strategy, then we're going to be able to have our data sitting in S3 because we're using AWS, and then enable multiple compute engines. And at the time, we had Snowflake, Databricks, but also Apache Flink, Athena, and Spark. So, and yeah, so that was a decision that we made. The data was sitting in Snowflake. For Iceberg, we needed to understand what does it mean to have Iceberg as the core table format. We understood so that Iceberg would give us a metadata layer, a bunch of files. I'll show you shortly, a catalog that we need to choose, and then we have our data files, which are locked inside at the time inside Snowflake. So we need to get that data out into our S3 layer. But it's good to understand what are the main components there. The next choice was, okay, we're going with Apache Iceberg. It was 2023. The Iceberg, while gaining traction, the support across the board 3 years ago is nowhere comparable to the support that you see today. So that was quite challenging as well. But one thing that we had to consider is, and especially if you want to consider this in your organization is the different types of catalogs that you will have. On top of the object storage where you have your data files, you will have technical catalogs. I mentioned Apache Hive with the meta store, which is what gives you the table-like view of your data files in the lake. Apache Iceberg itself defines a catalog. And then you can have, this is new, but with Delta, they're moving towards a catalog managed tables as well in Delta Lake. Some organizations have compute engines which have their own catalogs. You have platform catalogs, which is from your cloud providers or your data platform providers. Databricks provides Unity catalog. In AWS, we already were using the Glue catalog as well. So you can see how this can become challenging. And at the business level, we were introducing Data Hub. And so which one do you choose? Especially right now, even from the business catalog, some of them integrate with Apache Iceberg. So one of the most important decision you have to make is which catalog you're going to use once you decide to move to Apache Iceberg. One thing that we were clear is we want a catalog that supports a REST specification for Apache Iceberg. So Apache Iceberg documents and publishes the REST specification for its catalog access, and we wanted the catalog to support that. Wanted to be supported across different platform vendors and providers. And there were some other aspects that are important, although at the time were not available across the board. One is credentials vending. So you don't have static credentials to access the catalog. You can identify, depending on the role that you have, what data you can access or not. Federation, because we understood in organizations that are quite large, you can have multiple catalogs. So it would be good to have a way to federate from one catalog and have a view across multiple other catalogs. Role-based access control and catalogs that support branching and versioning, which is one of the features in Apache Iceberg. But at the end, we decided to go with AWS Glue catalog at the time. So that was a decision. And then the next step is, how do we start? And the start of the journey for when you want to do this type of migration is, how do you ingest into Apache Iceberg? So at the time, we were considering migrating some of the data in Snowflake that came from Apache Kafka. And we also had other data sources, but Kafka was the main one, and some scheduled batch loads, etc. There is, at least documented early this year, at least 9 ways to stream Kafka topics to Iceberg. You can use Kafka Connect, Apache Spark, Apache Flink. These open source technologies, they can easily consume from Kafka and ingest into Apache Iceberg. They have full support. In fact, Apache Spark was the first engine that had the support for Apache Iceberg. And then you have some of the data, some of the Kafka providers, they have ingestion already as a feature, like Tableflow from Confluent and WarpStream. They coincidentally have the same name. Red Panda, and recently AWS with the MSK Express clusters. I think this was last month. They announced that now they can ingest directly to Apache Iceberg as well. And then there's another, the Kafka native ingestion. It's an interesting one. Aven, AutoMQ, BuffStreams, Kansu.io. These are providers of Apache Kafka by implementing its protocol, not by providing the open source product as is. They have solutions where they can ingest natively to Iceberg. There's a bit of controversy in there. I can share some articles afterwards about that, but it's certainly one approach. And like I said, you can schedule batch load jobs to load into Apache Kafka, or do change data capture from relational databases using Flink or Debezium. In our case, in this particular migration, Kafka is and relational databases were the main operational sources, but we strategically focused on Apache Kafka. So a subset of the data that was in the data warehouse coming from Apache Kafka, we decided to migrate over to Apache Iceberg as a starting point. So for that, we used the Iceberg Kafka connector. And funnily enough, at the time, Tabular had not even released yet the Kafka connector for Apache Iceberg. But it came after we made the decisions, which was quite helpful. And we decided to deploy the Iceberg connector in our AWS infrastructure, using the AWS Glue catalog as the main catalog for this particular Kafka sources coming from that we're gonna migrate away from Snowflake, and we wanted to use ClakeFormation as a management layer for the data on top of S3. So that was a decision. We deployed the connectors. This is an interesting solution that we took in this particular case. We deployed a Kafka Connect connector per topic, and we had around 1,000 plus topics. And you can see here where this can go. So we have a connector per topic, and each connector was its own Kafka Connect cluster. You're going to have to manage quite a bit of that. So there's a bit of automation. I covered that towards the end. Or you can have a single Kafka Connect cluster with multiple connectors. But we went with the other approach to have full isolation. So different options there, how you deploy this.
While we are waiting for Karel to come back, I do actually have a poll that I would like to share with you all. So where are you currently at with your iceberg journey? And so we have a few options here. We're really curious about companies and their different stages of adoption at the moment. We'll see the responses coming through right now. We have some who haven't started yet. Hopefully this session is a good primer for getting going. Curious to see if anyone else is at a different position here. In production at scale, great, good to see, and I'm sure you've got some learnings as well that could be shared with all of us. Hopefully Karel will be able to come back in a moment, and we're seeing a few other options currently evaluating. Excellent. Hopefully these sorts of sessions and hearing from Karel's experience is a great way to understand some of the things to do and some of the things to avoid.
Yes. So sorry, I don't know how much you miss of what I was talking, thinking that everyone's listening to me.
Yeah, we heard you. We heard you.
Oh, excellent. So yeah, that's the approach that we follow. Like I showed before, there's like 9 ways to ingest Kafka data into Apache Iceberg. There's also change data capture. So the approach, it has to be chosen based on your particular organizational situation, what makes most sense in this case. The next important thing is, so you have your data now. We're using the Iceberg connector. We consume it from Kafka. One important thing to take into account when you're doing this type of migration is how you're gonna manage the schema. So one thing, if you're using Kafka, you're most likely using schema registry. That's a very standard approach of doing this. In our case, we wanted to have as part of the migration to Iceberg, this data, the Kafka data that was going to Snowflake, we wanted to put it in Iceberg. We also wanted to keep all the metadata around the Kafka records themselves, because we wanted to be able to run backfills and leverage the Iceberg data sets and be able to republish back to Kafka topics if required. So we use Cloud Events as a standard to use as an envelope for all our event publishing, and we have custom Cloud Event types and apart from the standards ones. So in that way, we could know if we had that information in Apache Iceberg, we will be able to know the schema and where it came from, etc. So it's important to know that, and for that, in Kafka Connect, especially if you use the Iceberg connector, where you have more control of what you do with the data, you can leverage the converters and the single message transformation to be able to accommodate and add more data as required into these headers. So that's an important one. The schema, I'll show you how TableFlow does that as well. But this is a schema that we came up with, and this was delivered. We wanted to have, like I mentioned, all the Kafka records in Apache Iceberg with all the information of the metadata for that Kafka record itself. So we have the value of the record, which is the structured view with Iceberg types of the schema of that record. And the value bytes is the actual byte. So if you're publishing Avro or protocol buffers into Kafka, the value bytes will be the corresponding binary of that record, and the value struct will be the Iceberg structured type view of that schema by using Apache Iceberg types. Event metadata is metadata around the particular event. So it could be an identifier, it could be the event time, the time that the event actually occurred. Kafka metadata captures lots of metadata around the Kafka record itself, the cluster that it came from, because we have multiple clusters, the topic, the partition, the offset, timestamp, and the headers. So in the headers map, then you have things that I mentioned before, like this type of headers that we add in Cloud Events. So it would allow you to then say for this particular, if you wanna to republish from Iceberg back into Kafka, you will have access to the schema ID and all the required information. And then archival metadata was something around the particular archival process. So if you're using Flink or Kafka Connect to do the archival, you can add things like, receive that, which is the processing time in the ingestion platform. So, but this was a highly custom schema. However, for the purpose of our migration, all the 1,000 plus Kafka topics that we had, they will all share the same schema as in the raw layer for Apache Iceberg. The thing that played in terms of having a proper standard way to then have the teams that are going to consume these tables be able to understand properly, that was, I think, a positive decision, reflecting back in how we went later on. So once we had the connector committing and adding files into Apache Iceberg in the Glue catalog, we configured Snowflake, which at the time was starting the support for Apache Iceberg, the access to the Glue catalog with a catalog integration at the time. And Snowflake runs periodic refresh in the catalog right now, so you can have your Kafka data going into Glue. In AWS, it could be another catalog, and then you can have your data warehouse if it has support. And in this case, with Snowflake, it has support to integrate directly with AWS Glue catalog. And like I said, it has the auto refresh. We had a commit interval to Iceberg every 5 minutes. So you have to think about your SLOs. Talk about it down the track in this presentation in terms of data freshness. But Iceberg was not created as a streaming solution. It was a table format to manage large data sets, and especially on the batch side of things. But in the current scenario setting for data architectures, the streaming is important because having availability of data as soon as possible is super important for application and for near real-time use cases. So we have 5 minutes. You can have 3 to 5 minutes. We'll talk about this soon. If you have a very short commit time, you're gonna accumulate in high streaming context multiple files that then you have to maintain. But in any case, we had this integration with Snowflake, but we needed to make sure that the availability of data was balanced with the amount of files that we were generating. So to control that, we set up Spark jobs to do periodic table maintenance. As being one of the main contributors in the decision-making process for this, wanted an aim to have the data platform do this maintenance for us. So this is similar to what, I guess if you're familiar with MySQL databases or any other relational databases, for the most part, as an application developer, you don't care first how the data is laid out on disk, and then whether there is some maintenance that needs to happen. Usually it's the data administrator, database administrator that takes care of this. But once you move towards an open table format, especially with Apache Iceberg, you will have to take care of this if you don't use a data platform that does its maintenance for you. And at the time, 3 years ago, this was not available, especially the way we were doing the ingestion, and we had to set this up ourselves. So Iceberg gives you quite a few primitives and documents really well how to do table maintenance. I think lately a few other organizations and companies working in this space have also published what are the best patterns to maintain your Iceberg tables. So this was a learning journey, and it did work for us. We set this up in a scheduled basis, and we had EMI jobs per Iceberg topic running with some jittering. So in that case, they wouldn't all of a sudden wake up at the same time and say, okay, let's maintain this Iceberg table. So you need to have some randomness into that process, so you don't overwhelm the catalog. And as I mentioned, so we had a large number of topics, over 1,000 topics, and that kept growing. So in order to set all this up, you need to have automation in place. That is something that, by all means, is super important. I'll talk a bit more about the automation aspect later on, but let me show you. I'm sharing my screen, and hopefully this can provide a better view on Iceberg. So we have we've been building this product. Factor House is called Igloo, and this is gonna give you a visibility on your Iceberg tables, and it will show you. Well, at this stage, it's not yet there. It will show you metrics and graphics about what is wrong with your Iceberg tables. As I mentioned, with the maintenance, especially if you are ingesting from Kafka, and we do provide visibility to Kafka classes. If you have a short interval commit time, you will accumulate lots of files, and you need to make sure that you compact in time. Oh, this is oh yeah, it's authenticated. That you do the compaction in time so that the queries on the data warehouse side or the query engine that you use is performant enough. The more small files you have, the poorer it's gonna be the queries, because all this data is sitting in S3, and the query engines we have to ultimately inspect that data. It also depends, obviously, on the partitioning that you have. So right now we integrate with we have this product Igloo I'm working on. We integrate with the AWS Glue catalog and TableFlow for Confluent. So this is the view on the Glue catalog. I have some Iceberg tables that I've been setting up with this is a demo use case with transactions, suppliers, products, etc. And you can look at with Apache Iceberg on every commit that you do. So for instance, in do we have so in the product table, we have snapshots. So every time you do a commit to an Iceberg tables, it will create a snapshot. That's what allows Iceberg to do queries where it can take you back in time. It's like, give me the view of the data as of this time. So we understand that for Apache Iceberg at scale, like the one that we had, thousands of tables, hundreds of tables, you need to have visibility and understanding of what's going on in your data lake. So you can look at the schema of the versions of this, what we're building here. You can see, for instance, that at version 0, when it started, it had an initial schema, the table, and you can look at the schema. It's multiple fields. And later on, you can see in the latest schema where a type got added. You can look at the fields of the schema, and you can do a diff with a split view against version 1, for instance. So you can see that the schema ID changes, and you can see that this type, the weight in kilograms, was a decimal that was expanded to 8 size. So this is what we're building. You're gonna have metrics and graphs with what the problems that we can detect on the Iceberg lakehouse that you have set up in the catalogs that you configure. We look at different namespaces. This is the only one that has Iceberg tables. We're gonna show data around the partitioning of your Iceberg tables. So in Iceberg, you can partition the table using transformations. So you can have a view on that. I'm not going into details about Iceberg itself because there's plenty of information out there. But what I wanted to show is that in terms of visualizing your tables across different namespaces and understanding the major problems, this is something that we understand that is super important to be able to be effective, and we're working on it as we speak, literally. So that is, and also we interface with, so we have the table flow integration as well happening. At the moment, we only have one table that I can show. So let me show you this one. This one is interesting. If we compare it against the schema that I show you that we chose in this particular migration, with Tableflow Confluent, they also add their own metadata columns, but they flatten it. So you can get the topic, partition, and the Kafka headers as well. So you can see all that in Tableflow. It gives you all that information. You need to understand then that all the columns that start with double dollar sign, are metadata columns were added by Tableflow. So we continue our journey with Igloo. There is a early access in factorhouse.io/Igloo. You can keep informed how we progress. But we're talking about the automation. So at the time, and this is all dependent on the organization's usage of infrastructure as code. So GitOps is, I think, quite mainstream now, where we use the infrastructure definition using Git as a source of truth. We had an internal tool to do this ourselves, but it's not difficult to build. There's there's lots of support in terms of Terraform, like creating Terraform modules to create your Iceberg table. If you're in the AWS cloud with Glue, you can create Iceberg tables with Terraform quite easily. Then in the way we did it, we had a solution that the product engineers could define the Kafka topics using some YAML or HCL. It doesn't matter for this purpose. The important thing is that it could go and can be defined in Git, and we, the data platform team, were not in the middle as a bottleneck to approve and decide that, yes, you can deploy this. So we had the infrastructure, the data platform infrastructure that will allow the product teams, and you have thousands of engineers. You don't want to be the single team being in the middle of these approval processes. They could deploy using GitOps and some form of definition, declarative definition that they want to deploy a Kafka topic. And they could also say, I want to ingest this Kafka topic into Iceberg. And by doing so, it would trigger and provision the infrastructure that I show you, where you have the Iceberg connector with the correct AWS Glue configuration and lake formation permission, so that the ingestion will proceed successfully. But this is very important, especially if it is at scale. I just mentioned, well, I show you Igloo. In general, once you have such a large scale migration of thousands of topics or tables in general, you want to have observability and metrics. And Apache Iceberg gives you lots and lots of information in its metadata, as well as on the reporting side on the right path. So the Iceberg gives you metrics reporters that with the Iceberg connector you can configure, and you can push towards the logs, different metrics, commit metrics. But then in the metadata, you can also get database level metrics, and you can get graphics such as percentage of active small files, because that, this is the red arc that you can see there. If you have too many small files, it's a sign of potential problems for your queries to have poor performance, and as well as many other metrics. But you need to set up observability. There's no way around that. And then for particular tables, if there is some issue or problem, you need to have table metrics as well at the table level. Again, looking at the small files for the table, different trends. There could be backfills that created a huge amount of data. This kind of thing, if you don't have visibility, it's going to be very hard to attend to on-call issues. And talking about on-call, so we set up SLOs. Doing a migration, it's important to show up all the errors. So this it was quite noisy initially, but then through some improvement that slowed down. But you need to have monitor for different metrics and SLOs, especially the ones that you care about. So Kafka Connect task errors, for instance, you have a connector failing. There was a backwards incompatible change to the schema, and all of a sudden it break. So you get woken up. You solve the issue. Kafka consumption lag is your ingestion into Iceberg lagging or not, especially when there's issue with the connector. Data freshness is, you want to have the data as soon as possible into your Iceberg layer, because later on, that raw layer, you're going to have data warehouses integrated into it. And in our case, it was Snowflake. And Snowflake had the view of the AWS Glue catalog, but it had to refresh every 5 minutes the metadata. So with 5 minutes commit time and Snowflake 5 minutes the metadata refresh, you have worst case scenario 10 minutes of data freshness. So you have to, this is a balancing act. Data quality as well. Doing this ingestion during migration, you need to have completeness and accuracy checks. You want to make sure that you have not dropped data. And also you want to make sure, and this was important in our case because we're using the Iceberg connector, the open source connector, with our own converter and lots of single message transformations. You want to make sure that you didn't modify the data. So you need to do some sampling, make sure that the data is correct as it was in Kafka, has not been modified. But that is very important to have in place, something to think about. And then you need to have a shared support model. In this particular instance, when you have a large number of tables, if you're ingesting, this applies as well for database tables, but I'm focusing on Kafka specifically because we were very very intentional on not to replicate relational database tables into the lakehouse. We wanted that to be via integration events that were published to Kafka. It could be to Kinesis Stream, it could be to some other distributed commit log, but we wanted to minimize, that was an architectural decision across the board, to ingest different, when you have hundreds of services, each of them with their own relational database, you don't want to be uploading those tables into the service. You want integration events, which are more bounded to the domain of that service, going to Kafka, going into Iceberg. So that's why the whole focus on Iceberg. But you need to have a shared support model because you have a large number of tables, either from Kafka topics or some other sources, and you don't want to be responsible as a data platform team for all of them. So we had a shared responsibility model where the product team were on call for issues that they caused themselves. So you could, if you incorrectly configured the ingestion of the topic, or you make a backwards incompatible change to your schemas, although we have that check in the CI/CD pipeline for some topics, or it didn't, for some schemas, it did not happen in CI/CD, and that caused lots of issues. But then the product teams will be responsible for that. We're responsible for infrastructure failures, which we also monitor as well. So having that shared responsibility will allow you to have then a more sustainable practice from for the data platform team.
Karel, we've had quite a few questions come through,
and
I'm just conscious of time, and so let me know if you'd like to start tackling some of those questions, or if you want to breeze through the learnings, whatever you prefer.
I'll go quickly through the learnings, so we're getting towards the end. Let me share some of the learning as well. I think this is one of the main goals in this migration is, you have to think quickly when you're migrating, how you're going to migrate to Iceberg. There are three main strategies you can do in place migration. If you have Iceberg tables, Hive tables, Iceberg gives you a system.migrate primitive that you can migrate Iceberg tables. You can do a full rewrite, but it's not practical once you have services consuming, but also terabytes of data. So the only same way that I can see is doing an online migration, and this is what we did. we had the legacy pipeline ingesting into Snowflake. We started ingesting from Kafka into the new Iceberg tables. We backfilled the historical data from the Snowflake database into the Iceberg table. Then we ran data quality checks, the completeness and accuracy check that I mentioned. And then via views that we had set up, we updated the consumers slowly. So you need to be strategic how you're gonna be doing your migration. We decided to migrate 1,000 topics, but it wasn't a one-off thing. It was very strategic in terms of incremental based on the most important tables. Avoid an all or nothing migration thinking. And you have to take into account that in some cases you need to backfill historical data, so you need to build tool for that, and also for free processing in case that something goes wrong during that process. We had issues with Snowflake. Some schemas were quite large in protobuf, so if you have 1,000 column, it can lead to issues. And I think AWS Glue also has limits that we ran into. But you should enforce contracts and schema for your Iceberg table from the beginning, especially if coming from Kafka. Use vendor credentials for the catalogs. It's easier. It gives you scope, short-lived credentials to access the catalog based on the role that is accessing. At this point, let's answer some of the questions, Toby, based on time. But
fantastic. All right, we're going to jump right in. You should see the questions pop up on the screen. The first one's from Patrick. So what's your specific architectural approach towards CDC for Iceberg tables in production? Thanks for the question, Patrick.
Thanks, Patrick. Yeah. So I have not had production experience doing CDC to Apache Iceberg, although I am familiar with the topic. In my personal experience, we're using Divisium to ingest from relational databases from some of our services into Apache Kafka. And from there, then you can ingest into Apache Iceberg. The main issue there is that you need to take into account with Apache Iceberg. Once you have change data capture, there's going to be instead update deletes going to the Apache Iceberg table. And in Iceberg, there are different modes that you can write to the table. You can do copy on write, which copies the data file over with the new changes, or you can do schema on read. What is it? Yeah. So you copy on write. I'm blanking out. But then you can. The other way is when you resolve the data on read, where when you do change data capture, all the insert and updates and deletes, especially the updates and deletes, will create in Iceberg what is called delete files. That's not a problem itself, but it's something you have to take into account for how you're gonna do the writing. If you have, let's say, 512 megabytes of packet data, and there's only one single update that went into the table, you don't want to overwrite the whole 512 megabytes to update only that. So you need to have read resolution as opposed to copy on write. But in terms of architectural approach, I mentioned Divisium. There are I think there's some technologies out there that will do the straight ingestion from relational databases into Iceberg. So AWS DMS, which is the data migration service for AWS, will do that. There are some other SaaS tools that will do the same thing. There's quite a few of those. Fivetran is one of them that comes to mind that you might take a look at. But as a general approach, I mentioned before, I would prefer not to do this, replicate tables from relational databases into Apache Iceberg, and I prefer to have integration events for that. I don't know if that answered the question.
Thanks, Karel. I'm going to move on to the next one just because of time. So this was a question, I believe, regarding Igloo. And so this is from Sarisha. Is it only for AWS? Will Azure and GCP be supported in future?
Yeah, so we intend to support all the major cloud providers. At the moment, we're focusing on AWS Glue and Confluent, but Tableflow, but we will support all the catalogs and major cloud providers. Yes.
Excellent. Thanks for that. And just a reminder, do sign up for early access, and then we'll reach out and have a conversation one-on-one with you and Karel, and you can help shape the future of the product. Another one regarding Iceberg, and a very timely one as well from Matthew. May an agent monitor and update? What's your thinking about that and the future of Iceberg, Karel?
Oh, when you say agent, is that an AI agent?
Yes. Yes.
Oh, yeah, that's an interesting question. Definitely, there's especially from the observability point of view, there's lots happening not only in Iceberg where you have AI agents doing the monitoring and sometimes the resolution. So yes, that is a possibility. I don't know what you mean by update in this case. For the monitoring, yes. Updating the Iceberg table, is that what you mean by that? I would prefer not to have an AI agent do that, but definitely yes for monitoring and highlighting, for instance, potential next steps. I'm going to fly through these slides. Sorry, we're still answering questions.
We have a few more questions if you're good with those, Karel. Another one from Patrick. So outside of piping Iceberg metrics to Kafka for your telemetry or monitoring, what other approach would you suggest or advise to gather metrics? And do you do monitoring in the batch pipeline scenario?
Yes, so a batch pipeline that is ingesting into Iceberg. In Iceberg, this is documented in the open source solution. You can have what is called metric reporters. So if you're using, let's say, Apache Spark, you can configure your metric reporters to report on commits metrics as well as scan metrics. So you can have scan reports, you can have commit reports as well. So that's what I would recommend. Like I said, so Apache Iceberg itself in the metadata gives you enough metrics, but if you want metrics at the right time, you can use the reporters in your batch pipeline. It depends on the tool that you use, but once you're using like the most common tools, Apache Spark or even Flink, you will be able to set up metrics reporters. So if you search for metrics reporter in the Iceberg documentation, that would be one approach. Otherwise, the Iceberg metadata itself will give you some of the metrics.
I'm just going to send you one last question, Karel, and then we can wrap up your content. And so this one is, my understanding correctly that migration needs one to put up a whole new ingestion layer into Iceberg and new Kafka topic schemas?
Migration needs one to put up a whole new ingestion layer. So if your data is sitting in a data warehouse or in a data lake, there's different migration approaches. I covered briefly, I mentioned the Apache Hive one to do a metadata in place migration. But yes, so you have to ingest into Iceberg somehow. So if your data, like in this particular example that I'm putting, a real world experience where the data was locked inside Snowflake, then you definitely need to ingest it into Iceberg. We made the choice to do it to AWS Glue and S3. We could have ingested it. We could have used the Snowflake support for Iceberg and put it inside Snowflake, but that would have been a new ingestion. So we had to create new pipelines to ingest into Iceberg at that point because the legacy pipeline was ingesting directly to Snowflake. So in our case, yes, we needed to create a new pipeline for that. The schemas, we didn't need to change into Kafka. What we did was get in Kafka Connect, we enhanced the metadata for the record itself because we wanted to have more information in the Iceberg table about the Kafka record. So we did a single message transformation, and in the converter, we added more information, but the Kafka schema itself remained the same. So you don't need to create new Kafka schemas. You could potentially have a new ingestion layer into Iceberg. Yeah.
Fantastic.
However, in the case of Snowflake, I said that there's a big, huge difference what I'm presenting here 3 years ago, decisions that we made 3 years ago to what it looks like now. Snowflake has full support for Apache Iceberg, and maybe the migration would have considered different options and alternatives if it was something that we would decide to tackle on now.
That's a great reminder. And I feel like that's another talk in itself of what could be done differently now with the current status of things too. Karel, we are 5 minutes over time, but I will let you
yeah.
finish your last few slides. And it's great to see all of the questions come through. If we didn't get your question, we will follow up over email afterwards, but really thankful for all of those that came through.
Thank you, everyone. Yeah, I think that this towards the end, you still need one thing that I wanted to say is the medallion architecture, where you have your raw layer of ingesting sources and then cleaning that up, the duplicating, etc. I think it's still applicable with Apache Iceberg, especially because the partitioning of the Iceberg table has to be accommodated for the query access pattern. So if you partition the table in one way during ingestion, your consumers might want to query the table in a different way, and you have to accommodate and change that partitioning. So yes, I think that is still a valid point. One thing that I wanted to say is that ultimately, we should not care, we shouldn't have to care about the Iceberg. And this was in 2022, Ryan Blue, the creator, one of the creators of Apache Iceberg, he had that to say. That was in 2022. Unfortunately, in 2026, we still need to care about it, but they're converging. So between Delta tables, Delta Lake in Databricks and Apache Iceberg, they're converging. And the new versions, version 4 in Iceberg, they're gonna, one thing they're gonna do is focus on converging the metadata that Delta Lake tables from Databricks have, which is another table format in Databricks with Apache Iceberg. So they're trying to converge and remove that friction that exists still to this day between Apache Iceberg, Delta Lake, and the other table formats, but especially between Iceberg and Delta Lake. So yes, this is, I think, most of what I wanted to cover today. We've been through the Q&A. Thank you so much. I apologize for the restart of my computer. This unexpected, as it happens. But we have some code samples that I built if you want to play with Apache Iceberg. Remember the early access to Igloo for Iceberg in factorhouse.io/Igloo. I think Toby's going to share the recording.
Yes, you'll all get a recording after this, and yeah, feel free to share it with the rest of your team. And we hope to see you at a future Factor House Tech Talk. We run these every month on various topics, so you can follow us on LinkedIn, or you'll get email notifications about upcoming events as well. And we'd love to see you at the next one. But thanks very much for all of your questions and engagement today. It was a great session, and thank you, Karel, for presenting too.
Thank you. Thank you, everyone.
All right. Have a good day, everyone, and we hope to see you next time. Take care.